All right. Hello. Welcome everyone to the Stylus Pro series workshops. So we have today workshop 2, where we are going to talk about testing and tooling for Stylus smart contract development, right? My name is Jose Franco. I'm an integration engineer at Off-Chain Labs. Off-Chain Labs are service providers for the Arbitrum Foundation, and we're the first builders of Arbitrum, right? Okay, so first of all, if you are watching the recording of this session, it is highly recommended to watch workshop 1 first, since we are going to build on top of what we saw there. And if you are watching this live and you couldn't make it yesterday, don't worry, we'll try to make it as clear as possible so you can follow up, okay? But first of all, let's do a bit of a recap of what we saw yesterday. So yesterday we started talking about what is a stylus. We explained a bit what it is. Remember that it is a new technology that allows us to write smart contracts on Arbitrum chains using languages like Rust, C, or C++. Then we briefly touched the basics of Rust, of the language, to move then to the Stylus Rust SDK. Then we also talked briefly about the Stylus CLI tool called Cargo Stylus. We're going to talk a bit more about it today. And then we showed how to run a local dev node, and we showed also the counter contract example. So that's what we saw yesterday. And today, we are going to divide this workshop into 2. First, we are going to talk about testing Rust contracts. We're going to talk about unit testing and integration testing. And then we are going to talk about tooling that is available in Cargo Stylus as well. One tool to cache contracts into the Stylus cache, and then another tool to trace transactions. Okay, so let's get started. Now, testing Rust contracts. So what we are going to do here, for those who are familiar with Rust, if you're not familiar with Rust, that's all right. I'm going to explain it anyway. But I'm going to explain first how Rust handles testing, native Rust, when you're, I don't know, building a library for Rust. And then we are going to compare that to how we do tests using the Stylus SDK. They are very similar, but there are a few differences that I want to point out, okay? So, we have 2 types of tests that we usually implement when writing a library or a smart contract. We have unit tests and integration tests. Unit tests verify pieces of code in isolation. Think of unit tests like tests that you can write for individual functions in your library, right? So you have a library, you have, I don't know, multiple functions. So you usually write unit tests for each of the function. You verify that for a given input, you get the expected output, right? And those unit tests are written inside the same file that contains the function that you're testing. That's how Rust does it. On the other hand, we have integration tests. They verify entire flows that your library is expected to provide. So if you have a library and the intended use of that library is to call, I don't know, 2, 3 functions, with different inputs, and I don't know, make up something with that. So you want to test that whole flow instead of individual functions, okay? Those integration tests are implemented in external files. And they are implemented in external files because you want to import your library as an external entity would do, as an external developer or another library will do. All right, so how do we write unit tests in native Rust, okay, outside of the Stylus SDK? So as I said before, we write these tests in the same files where the functionality that is being tested lives, right? So if we have one file that contains a set of functions that the library provides, we want to write those unit tests in that file, for those functions in that file. So the way we do it is that we declare a new module called tests, where we implement the different tests. That module uses a specific attribute, CFG test, so it is only run when executing cargo test. Why we want to do it this way? So cargo test is going to build a specific image or a specific binary to run the tests that we've written. And we do it that way because we want to allow it to use some dependencies that we don't want to have in the released version, right, of our package. So we can have a different, we can have dependencies that are only used in the testing framework, and other dependencies that are used in the released version. Each unit test is implemented as an individual function inside that tests module, and each function is annotated with test. Okay, we're going to see an example now. Okay, so we have here a very basic example. We have a function called add that takes two parameters and returns the sum of them. And within the same file, we have this module called tests, annotated with CFG test, that imports that function and then has one single unit test. It works, okay? And it works. What it does is that it calls the function and asserts that the result that we get is the expected one. All right. So if you want more information about unit testing and actually integration testing in Rust, in native Rust, one of the best resources is the Rust book. Okay, I talked about this yesterday, but I'm recommending it today again. It's a great resource to learn and as a reference material. All right, so that's how Rust, native Rust, handles unit tests. Now, how do we write unit tests in the Stylus SDK when we are writing a smart contract? Smart contracts are slightly different than regular libraries that you will write in Rust, right? But in the end, the objective is the same. You want to be able to test individual functions of that contract in isolation. And we are going to write the tests in the same way, in the same file that contains the functions, okay? So for this, we are going to use a library developed by OpenZeppelin that's called Motsu. Motsu adds additional functionality to regular Rust tests, okay? So the reason we want this is because when we are testing a smart contract, we want to have available and easily available an instance of the contract initialized to be able to call methods on it, right? Also, we want to be able to call functions from the virtual machine, VM affordances, like, I don't know, getting the balance of the contract, for example. So all of that functionality is provided by Motsu on top of the regular testing framework that Rust provides. So the difference in this case is that we are going to write the test the same way, but we are going to annotate them with Motsu test instead of only test. And one final point that I added there was that they receive as parameter an instance of the contract being tested, which needs to implement the storage type, but don't worry about this because most contracts will implement that. As long as they have storage, they implement the storage type. Okay, so this is one example. So we have here a unit test for the counter contract that we saw yesterday. I have a snippet, a piece of that contract, just the getter, the number function, which just returns whatever it is in storage. So the unit test for that function looks very similar to how you will write it in Rust without the SDK. But in this case, we are using Motsu test as the annotation for it gets number for the function. And then we are passing a contract variable as a contract parameter for that function. Okay, that contract will be an instance of the counter contract. Then we just call the number function, and we just verify that it is 0 because it's just being instantiated. All right, so let's take a look at a more complex example here. There we go. All right, I hope you can see my screen. It has a good font size and all that. If I don't know, maybe write a comment if you can see it well, or if you can't, and I'll try to adjust it. Okay. Anyway, so we have here the counter contract that we saw yesterday. I think it's slightly different in the sense that, well, it has the same storage layout. It has the same functions like number and set number, but I think yesterday's one didn't have these functions. I'm not sure, maybe they did, but the rest is just the same, all right? And I've written down here the unit tests for all of these functions, okay? So I have my tests module here, annotated with CFG test. I'm importing the counter contract that I have above. And then I have one Motsu test function for each of the functions, right? In this one, I get I call the number function. In this one, I call the set number function, and then I multiply, add, and increment. One thing to notice here is that because each test is run in parallel, I have to, so we get our contract variable here, the one that we get by parameter, is always initialized to 0. So if for example, I want to test that it multiplies, I have to set one number first to be able to multiply it by another, okay? Otherwise, I will be multiplying by 0. All right, so how do we run these tests? Well, the way we do it is that we just run cargo test. And in this case, we are going to specify the leaf parameter because when we're writing smart contracts with the Stylus SDK, we need to have one lib file and one main file. And we want to tell cargo in this case that I just want to run the test for the lib file. Running them in the main file is okay, but I need to add additional features, and I don't want to do that here. So if we do this, we have the regular output of cargo test. It's running 5 tests. It gets number, it adds, it increments, multiplies, it sets number. So let's try to, I don't know, let's make one test fail here. So this one, for example, it increments. If I change the expected output and run it again, we see that one failed here, 4 passed, and 1 failed. And we can see the summary here. They all passed except it increments that failed. And we can see exactly why it failed. It says left is not equal to right. It's referring to the assertion that we're doing here, because left is 5 and right is number is 6. Okay, so that's not equal. That's why the assertion fails. Let's put it back to 6 and write 1 last time. There we go. Okay, so those are unit tests, okay? Let's move now to integration tests. Now, as I said before, we're going to do the same here. I'm going to explain first how native Rust or Cargo does it, and then we are going to see how we do it with the Stylus SDK, all right? So, as I said before, integration tests verify entire flows that your library is expected to provide instead of individual functions. And they are implemented in external files. So the way we write these tests is that we create a separate folder called tests, and every file in that folder is going to be a different set of integration tests. Okay, so if we place one file and we have, I don't know, 5 tests within that file, that's okay. It's going to run the 5 tests. Okay, but we can divide that as well into different files inside the tests folder, okay? We're going to see an example later of this. Now, in each one of these files, we are going to import the library as an external library will do, okay? And then we're going to write our tests in different functions that are going to be annotated with test. Finally, they are also run with cargo test. Okay, we can specify certain parameters to only run integration tests, and that's actually how we are going to run these tests. But you can just run cargo test, and it will run both unit tests and integration tests. All right, so this is one very basic example following what we had before, which was the add function. Okay, so in this case, this file, the contents, the code that we see here will be inside a file that's inside the tests folder, okay? And this file will just import the library, our library, and the function add in this case, and then we have just a basic test to verify that we are getting the expected result. All right, so let's now move to the Stylus SDK. Now, integration tests for smart contracts are a bit more complex, because in this case, we are not just importing one library, but in this case, we want to actually deploy the contract and run transactions against that contract, okay? So, but basically the objective is the same. We want to test entire flows that the contract is expected to provide, and they are implemented in external files as well. One example is that we might want to deploy the contract, set some storage values, transform them, and query them to verify that that flow works as expected. Okay, so because they are a bit more complex, we have a couple of requirements for performing integration tests in Stylus. One of them is that because we want to deploy the contract, we need an RPC. An RPC just to access the network that we want to access. For example, if we want to test against Arbitrum Sepolia, you will need an RPC of Arbitrum Sepolia. So you can call it to deploy the contract, to call the contract, whatever you want to do, okay? And the second requirement is that we need the ABI of the contract, because whatever system we are using to write the integration tests need to know the interface of the contract that it's going to call, all right? So if we have those two things, there is actually multiple ways of implementing integration tests. We can have, for example, a bash script that just uses Foundry Cast to deploy the contracts, or actually it will use Cargo Stylus to deploy the contracts, and then Cast to call the contract and modify its state. We can also use a JavaScript library like Ethers or VM. But in this case, we are going to use another library that's been developed by OpenZeppelin as well, and that's specific for integration testing. And that's the E2E library, okay? E2E library is actually the same as the Motsu library for unit testing, but in this case for integration testing. And the goal of the library is the same, is to leverage the way that Rust that Rust uses to write integration tests, but adding the functionality that we need to test smart contracts. Okay, for example, it allows us to deploy contracts, to call functions through the RPC. It allows us to access VM affordances, well, because we are calling the RPC actually. And we are going to write them the same way we write in regular integration tests, but in this case, we are going to annotate them with E2E test, okay? So this is one example. This is actually a basic example that just deploys the counter contract and calls the number function. It might seem a bit complex because actually, these libraries, both E2E and Motsu, are still in development. They are usable right now, and they are very powerful. But if you are not used to the nomenclature to how you use them, it might be seen a bit complex. Okay, so what we're doing here is that we have our deploys test. It is annotated with E2E test, and it's receiving an account as a parameter. Okay, and we are using that account to deploy our contract, because this is inside of the counter contract project. It knows it has to deploy the counter contract. So once it deploys it, it creates a new variable that is bound to the contract deployed, and then it just calls the number function and verifies that the number is actually 0 because we just deployed it. Okay, let's see now the code of it. So they're telling me that the code might not be big enough, so I'll try to make it. Okay, I hope we can see everything now. All right, so let's go to the integration tests file. Now, as you can see here in the left sidebar, we have our scripts folder here, we have our src folder here, and we have our tests folder. All right, inside the test folders we have one single integration test file, and we have a folder called ABI because we've added the ABI of the contract here. Remember that we needed both an RPC and the ABI of the contract, so we've added the ABI here. To get the ABI of the contract that you are developing, you can just use cargo stylus export ABI, and that should give you, yeah, here it is, the interface of the contract. Actually, the ABI. This is actually what I had written here. So let's take a look at the integration tests. All right. So in this case, in this file, what we're doing is just we are importing the E2E module. We are importing the ABI that exists in the one that we just saw in the ABI folder. And then we have three tests: test 1, test 2, and test 3. All right. So test 1, actually, this one doesn't use the counter contract, but I wanted to show you how you can access VM affordances. In this case, we are just going to verify that the Alice account has some funds. Okay. So we are going to call the get balance method here for that address, and we are going to verify that it has 100 ETH. Okay, this test is a bit special because, I mean, we know what environment we are using to run this test, so we know that Alice is going to have 100 ETH. And the reason we know it is because we are going to run these tests against the dev node that we saw yesterday, the local dev node that we saw yesterday. Okay, I'll explain later how to run this test and how to run the dev node again. So this is the first test. The second test is the one that we saw in the slides. It just verifies that the contract deploys and that the storage is the state is initialized to 0. Okay, and the third one is going to deploy the contract as well, and then it's going to call all the functions that we have in that contract. So first we get the number, which should be 0. Then we call the increment function. We get the number again, so it should be 1. We add the number 5. We multiply that by 2. And then we set a new number. Okay. So we just, it's not the usual flow that you will write for integration test, but it's also not the usual contract that you're going to work with. Anyway, so how do we run these tests? Now, as I said before, we need the ABI that we have already, and we need an RPC. And actually, for the RPC, we need a network. We need to decide in which network we are going to test, right? So in this case, we are going to use a local dev node to test our contract. And to make it easier, we have a script here that's called, it's in scripts test nitro test node that, what it does is just actually to clone the nitro test node repository. This is the code of the local dev node, and just run it. Okay, I'm not going to run this because I'm already running it in the background. But just so you know that you can do scripts tests nitro test node, and it will run the test node. Okay. Another thing is that at the end of the presentation, I'm going to show a QR code that goes that points to this repository. Okay, and I think in the notes after the workshop, we are going to also share the link to the GitHub repository. All right. So once we have our node running, we can execute the cargo test command, but we are going to use some parameters to only run the integration tests. So for that, we have also this test E2E file that just verifies that the contract is valid, and then it creates this environment variable RPC URL, because this is the one that the E2E library is going to use, okay, for running the integration tests. And this localhost 8547 is pointing to the local dev node that we are running. And then we just run cargo test, specifying that we want to run the file called integration test, the one that we have here. And we need this feature because it's going to pass through the main file, and we don't want it to do weird things there, basically. So we're just gonna run scripts test E2E. It's going to verify that everything is correct. There we go. That's cargo stylus check, and then it's going to run the cargo test command. There we go. Now it's running 3 tests. Test deploys, test accounts are funded, and performs all operations. Okay. So there we have it. Let's do one thing here. Let's change some of the tests so it fails. We're going to change 2 tests, the one that adds and the one that multiplies, because I want to show you guys something. We're going to run the test again. Test, that one is okay, that one is okay, and the last one failed. Okay, so we have 2 passed and 1 failed. And when we have one test that fails, E2E, the library, actually gives us information that is very useful. For example, it gives us the RPC we are running the test against. We get the address of the contract that was deployed, and then we get the regular reason why the test failed. Okay. One thing to notice here is that the test is failing at line 65, right? Which is this one here. It's failing in the add-in function, right? But nothing else is reported. So that means that execution stopped here. This is something to keep in mind when you're writing tests, right? All right, so let's put it back to how it was and run it once again. There we go. I'm gonna run once again, running 3 tests. There we go. So everything is okay now. All right, so this is integration test. Let's go back to the presentation. Okay, so yeah, to sum up, so we've seen testing, we saw unit tests, integration tests, and now we are going to go to the second part, which is tools available in Cargo Stylus, okay? And we will start by talking about caching. But before talking about caching, let's do a bit of a recap of the Cargo Stylus CLI tool. For those who weren't here yesterday, Cargo Stylus is a CLI tool that performs operations on Stylus contract, and we have well, several examples there. If we use Cargo Stylus check, we check whether a contract builds and is compatible with Stylus. If we use deploy, we deploy the contract to a chain, and we already saw an example with export ABI, which displays the ABI of the contract. All right, caching. So why do we need to cache our Stylus contracts? So just to explain a bit how it works, when we access a Stylus contract, because we are running a transaction through it, what happens at the node level is the node is going to get the bytecode of that contract, and it's going to load that into memory. All right, and this is like this initialization process that all contracts go through. But that process is it's a bit expensive, all right, and you have to pay the gas for that. So that means that if you are calling the same contract multiple times across multiple transactions, you have to pay that initialization process each time. So what caching does is that it tells the node when you cache, when a contract is cached, it tells the node to load that contract into memory and to leave it there. Okay, so when you access that contract that is cached, that initialization process is not going to happen because the contract is already in memory. So you are going to save, you're going to cut those costs, those gas costs. Okay. Now, the cache also operates through an auction system. Okay, so when you want to have your contract cash, you bid for your contract to be cash with a certain amount, right? With one way, two way, I don't know, the amount that you want based on what is already in the cash. Okay, the cash is going to tell you, okay, what is the minimum bid for your contract to be cashed, and whether the bid that you added is enough or not. Okay, if you want, I don't want to go too in depth, too deep into this, but if you want more information, just go to docs.arbitrum.io. In the Stylus section, there is a caching page that goes through all this process. All right. Okay, so we can use Cargo Stylus to cache our contract once we have deployed it. Okay, so after deploying, we can use Cargo Stylus cache bid and bid for our contract to be added to the cache. Once the contract is in the cache, we can check its status by calling the status subcommand, and we can pass in the contract as an address. All right, we're going to see how that works. Let's go back to our counter contract example here. So the first thing that we want to do is to deploy the contract, right? Stylus deploy. We already verified. Well, let's do the full process. Let's first do a Cargo Stylus check, just to verify that everything is correct. Let's do now deploy. So we need to specify the endpoint. I have everything loaded into environment variables. We have to specify the private key. You usually wouldn't do it with environment variables, but you can also use a path that contains the private key, and there are other options for specifying the private key. Okay. So we deploy that. When using deploy, usually takes a bit of time because it makes some sorry, how do I put this? It verifies certain things on the contract based on the Rust version that you want to use. Okay, because for different Rust versions, it might behave differently. Okay, so now our contract is deployed into our local dev node. All right, so we have our contract address here. We are going to save this into a environment variable. There we go. And actually, when we deploy the contract, Cargo Stylus deploy is going to tell us, hey, we recommend running Cargo Stylus cache bid, blah, 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 0 to cache your activated contract in RBOS. Okay, so it's already going to recommend us to cache our contract. Now, we're going to do this now. But since I already cached the contract before, this is probably going to fail. Don't worry about that. I'll explain why. So L2, there we go, specify the, cache bid. I need to specify the contract address here, the bid 0 because nothing is cached, then the private key. There we go. So yeah, it's going to tell us that Stylus contract is already cached. If it wouldn't be cached, it will just tell us that it's been cached, and that's it. Okay. And actually, you can see that this bytecode is cached. If we do cache status, endpoint, local L2, and the address, which is a contract address, right? There we go. So it tells us that the contract address here is cached, okay? Because I cached already a contract that had the exact same bytecode. So the bytecode is already loaded into memory in the nodes, okay? And so also Cargo Stylus cache status, even if we don't pass the address, it's going to give us this information, where the cache contract lives, if it is active or not, how full is the cache, so it still has a lot to cache. And it tells us here as well, cache is not yet at capacity, so bits of size 0 are accepted. Oh yeah, right. Because I used the bid, I used 0 for the bid, right? I used bid, the contract address, and 0. That means that I'm bidding 0 way to cache my contract, and that is possible because the cache is not full yet. The moment the cache is full with 0-bit contracts, then anyone who bids one way is going to be able to access the cache, okay? But you won't be able to access the cache with zero way bits. All right, so that's caching. Let's go back to the presentation now. As I said before, if you want to have more information, just go to our documentation portal and you'll find more information there about that. Okay, next, this is the last part already. Tracing Stylus transactions. So we can use also Cargo Stylus to get a trace of a transaction that's already been executed on chain. What Cargo Stylus trace gives us is an object that looks like debug trace transaction, okay? And it contains the different functions that have been called and how much ink they used, okay? Ink, for those who are not familiar with it, is a unit of measure that is smaller than 1 gas. So actually 1 gas equals 10K ink, just for you know. Okay, so how does a trace look like? So we're gonna have like different functions that are called, so different steps in that trace, and each one of the steps is going to look like this. In here we have, for example, we have name. Name is the name of the function that was called. Args is the parameters passed to that function, or the arguments. Outs is the output of that function. And then we have end ink and start ink, which is the ink that we started with and the ink that we ended with after calling with args. A few notes on this. For now, only calls to host IOs are traced. Host IOs are specific functions that live inside the Stylus virtual machine. So those are the ones that are traced. And OP codes are not shown in the trace yet, okay? If we subtract start ink from end ink, we'll give you the exact ink used for executing that step. Code that is executed in between calls to host IOs is not shown. You're going to see a full example of this, so you'll understand what this means. But for example, if you have one call to a host IO and then you have a bunch of, I don't know, if conditions that you want to check, or I don't know, some certain things that you want to do there, those things will not be traced, will not be shown in the trace, okay? And out contain the byte representation of the output of the operation. Okay, let's check an example now. So what we're going to do now is that once we have now our contract deployed, so we are going to make a few calls to it and see how one of them look like in the trace, right? So we're going to start by just calling local L2 contract address. We're just going to call the getter now, which is number. Sorry, like this. Oh yeah. Wait, what? Cast call local. Oh yeah. I need -r here. There we go. So we have 0 here because it is we haven't done anything with it. So we do now a send. We add the private key here. Local private key, contract address, and then we're gonna call increment. Right? Increment doesn't return anything. Okay, so that's our first transaction. If we call again the getter, we get that now the number stored is 1. We're going to increment again, and we call the getter again, and it's 2. All right, so we're gonna get this last transaction, the one that incremented from 1 to 2. And we're going to store that into an environment variable there. There we go. Okay, now we're going to use Cargo Stylus trace against our local node. And we're going to pass the transaction that we just executed. Now we have this bunch of information here that I'm going to format for you guys. Whoop. Let me see if I can grab this here. There we go. And then we create a new file here. This, and format. There we go. Okay, so these are the different steps that we've executed here. Let me see if I can remove this. I think I can. Yeah. Okay. So you're going to see that the first step that is called, or the first function that is called, is user entry point, and then message pre-entrant, and then pay for memory growth. But actually, if we go to the increment function, we don't see any of that. In the increment function, we just see that we get something from the storage, and then we save something in the storage, and that's it. So what are all these calls, right? So remember that yesterday we talked about the Stylus SDK, we talked about Rust, and we talked about macros. And we said that macros generate code from another code at compile time, and that the Stylus SDK uses a lot of macros. So all these functions are what's happening behind whatever we write in our contract when using the Stylus SDK, because we are using a bunch of macros. There's a lot of code that we don't see when we are developing, but actually when we deploy that on chain, that's the code that gets deployed, okay? So if we want to take a look at what is actually deployed on chain, or what is the final code that is compiled the final code that we get after compiling the contract, we can use cargo expand, okay? This is a library, so you will have to install it if you want to use it. But just so you know what it looks like, if you use cargo expand live in our project here, we get all this code that is the actual code that we get after compiling the contract, okay? I've already taken all of this and pasted here so we can easily see that. So we see here our counter contract. We will see probably down here the functions, I think. Yeah, here are the functions, and this is all code that is needed for the contract to work with Stylus, with the Stylus, okay? So when we trace a transaction, the trace is going to show us information from the expanded code, okay? And in this case, user entry point is a special function, which is the first function that is called when accessing a Stylus smart contract, right? And we can see what the code is here. There we go. So this is the code. This is the first function that is called when accessing the Stylus contract. We have user entry point. So we enter here. We get some length, a parameter called length, and it's actually the length of the call data that we've sent. If we take a look at this, we get a 4 bytes, because 4 bytes is the selector of the function that we called, because we didn't pass any parameters or anything. The only call data that we used was the selector of the increment function. Okay, so that's the user entry point. And the next one is message pre-entrant, which is the next call that is made here. Because in this message pre-entrant just checks if the call to this contract is re-entering the contract or not, because we have disabled re-entrancy for this contract, or we haven't enabled re-entrancy for this contract. If the call is re-entrant, we just return an error here. Okay, so the next one, that's message re-entrant. So the next one that we have is pay for memory growth, read args, and message value. But we don't see this here, because the next one that we see is args. So all those host IOs are called inside the args function. The args function is going to do 3 things. First, it's going to allocate some memory by calling pay for memory growth. Then it's going to read the call data that we get and load that into memory. So we get the output of that read args, which is this hexadecimal code. And if we do cast 4, it should give us increment. There we go, increment. And then it gets the call value in case it loads the call value in case we've added any value to it, right? So that's what args does. And it returns, the input as we saw. The next call is in the expanded code is the entry point. Okay, we are going to see in the trace that after message value we have already this storage load and storage cache bytes. These are the actual accesses to the storage. We are loading something from storage and writing something to storage. So what's happening here is that in the if we look at the expanded code, this entry point function is called, and it's here. And what it does is, based on the input of the call data, we are going to get the selector of the function. We get the first 4 bytes, which in this case is just the whole call data. We get the selector, and then we call the actual function based on that selector. Okay, so we are going to call the increment function here. And if we go to the increment function, there we go, we have our access to storage and our write to storage. Okay, so take a look at this. This is important. So we had message value, which was the last host IO that was called in the args function. And then we did a bunch of operations there, and we ended up with the storage load bytes, right? So all those operations are not traced here. Okay, just keep that in mind. So we have our storage. So we load the information from storage. We write it to storage. We can see that the arguments for load is the slot number that we are accessing. In this case, is 0 because we have only one storage variable, and the output is the value that is stored there, which was 1 because we were incrementing from 1 to 2. And then when writing, we pass the storage slot and the new value, which is 2. Okay. After that, we have a call to storage flash cache, which is already after the entry point. So after calling the entry point, whatever we did with the storage, before finishing the execution, we are going to flash the storage. So everything is persisted. Okay. And finally, we have write result, which is called within output. This is going to, whatever we're going to give as a result of the execution of the contract, we are going to write it from memory to the buffer that we're using to send that information to the user, right? So that write result is called within output, and then we have the final function that is always called, that is user return. Okay, user entry point is for starting execution, and user return is to finishing execution. All right, that was intense. That's tracing. Okay, if you have any doubts about this, just go to our Discord or Telegram, and we are more than happy to help you answering these questions. All right, and I think that concludes what I wanted to show you today. Yeah, there we go. Okay, so here we have the QR code that goes to the repository that contains the project that we just saw. It has all the code, all the tests, the unit test, the integration test, all the scripts that you can use to test, to run the dev node or the unit test, the integration test, all of that. And you have also here the Telegram and Discord links, and also the link to the documentation portal. So thank you very much for your time, and I hope you enjoyed the presentation, and hope to see you tomorrow again for our complex example using Stylus. Thank you. I think we can